Data scientist tools. Data scientists rely on a wide range of tools to analyze and derive insights from data. These tools encompass various stages of the data science workflow, from data collection and cleaning to modeling and visualization. In this explanation, I will provide an overview of some essential data scientist tools within a 1,000-word limit. 1. Programming languages. Data scientists often use programming languages for data manipulation, analysis, and modeling. Some popular programming languages for data science include Python, widely used for its rich ecosystem of libraries such as NumPy, Pandas, and scikit-learn, which facilitate data manipulation, analysis, and machine learning. R, particularly popular in statistical analysis and data visualization. R offers a comprehensive collection of packages like ggplot2 and dplyr. SQL, structured query language, SQL, is essential for working with relational databases, allowing data scientists to extract, transform, and analyze data. 2. Integrated development environments, IDEs. IDEs provide an integrated environment for coding, debugging, and executing data science projects. Some commonly used IDEs for data science are Jupyter Notebook, Jupyter Lab, provides an interactive environment for data exploration and analysis with support for Python, R, and other programming languages. It allows for the combination of code, visualizations, and explanatory text in a single document. PyCharm, a powerful Python IDE that offers features like code autocompletion, debugging, and project management. RStudio, a dedicated IDE for R programming that provides a user-friendly interface, code editing features, and integrated debugging tools. 3. Data manipulation and analysis. To clean, pre-process, and analyze data, data scientists employ a variety of tools, including Pandas, a Python library for data manipulation and analysis, offering data structures and functions to efficiently handle structured data. dplyr, a popular R package that provides a concise syntax for data manipulation tasks, including filtering, sorting, grouping, and summarizing. SQL databases. Tools like MySQL, PostgreSQL, and SQLite enable data scientists to store, query, and manipulate large datasets using SQL queries. 4. Machine learning and statistical modeling. Data scientists heavily rely on tools and libraries for building and training machine learning models. Some widely used tools in this domain are scikit-learn, a comprehensive Python library that provides a wide range of algorithms and utilities for machine learning tasks, including classification, regression, clustering, and model evaluation. TensorFlow, an open-source machine learning framework that offers a flexible ecosystem for building and deploying machine learning models, especially for deep learning tasks. PyTorch, another popular deep learning framework in Python that provides dynamic computational graphs and advanced functionality for neural network models. Carrot, an R package that offers a unified interface for machine learning algorithms and provides functions for data preprocessing, model tuning, and evaluation. 5. Data visualization. Effective data visualization is crucial for conveying insights and patterns present in data. Some tools for data visualization are Matplotlib, a widely used Python library for creating static, animated, and interactive visualizations, providing extensive customization options. ggplot2, an R package that implements the grammar of graphics, allowing data scientists to create visually appealing and customizable plots. Tableau, a powerful data visualization tool that enables users to create interactive dashboards and reports without programming knowledge. 6. Big data processing. When working with large-scale datasets, data scientists utilize tools designed for distributed computing and big data processing. A few prominent tools are Apache Hadoop, a framework that enables distributed processing of large datasets across clusters of computers, with support for the Hadoop Distributed File System, HDFS, and MapReduce programming model. Apache Spark, an open-source cluster computing framework that provides fast and scalable data processing capabilities, including batch processing, stream processing, and machine learning. using its resilient distributed dataset (RDD) abstraction. 7. Data integration and ETL. Extract, transform, load. Data scientists often work with data from various sources and need tools to integrate and transform it. Some tools in this category are Apache Kafka, a distributed streaming platform that enables data ingestion and real-time data processing, making it useful for streaming data pipelines. Apache Airflow, a platform for orchestrating and scheduling data workflows, allowing data scientists to define and automate complex ETL pipelines. Talend, an open-source data integration tool that provides a graphical interface for designing and executing data integration workflows. 8. Cloud computing platforms. Cloud computing platforms offer scalable infrastructure and services for data storage, processing, and collaboration. Notable platforms include Amazon Web Services, AWS, provides a wide range of services, such as Amazon S3 for storage, Amazon EC2 for computing, and Amazon Redshift for data warehousing. Microsoft Azure offers services like Azure Blob Storage, Azure Virtual Machines, and Azure Synapse Analytics for data storage, computing, and data analytics. Google Cloud Platform, GCP, provides services like Google Cloud Storage, Google Compute Engine, and BigQuery for data storage, computing, and big data analytics. 9. Version control systems. Version control systems enable data scientists to track changes in their code, collaborate with others, and maintain project history. Popular version control systems include Git, a distributed version control system that allows for efficient collaboration, branching, and merging of code and project files. GitHub, a web-based platform built around Git, providing hosting for code repositories, collaboration features, and integration with other development tools. GitLab, an alternative to GitHub, offering similar functionality with the option for self-hosting the repository. 10. Note-taking and documentation. Effective note-taking and documentation are essential for reproducibility and sharing of data science projects. Some tools in this category are Jupyter Notebook, Jupyter Lab. Besides its coding capabilities, Jupyter allows the creation of interactive documents containing code, visualizations, and explanatory text. Markdown, a lightweight markup language used for creating formatted text and documentation that can be easily converted to HTML or other formats. LaTeX, a typesetting system widely used for scientific and technical documentation, providing high-quality typesetting and mathematical equation support. It is worth noting that this is not an exhaustive list, as the data science landscape is continually evolving, and new tools emerge regularly. Additionally, the choice of tools may vary based on individual preferences, project requirements, and the specific domain of data science being explored. However, the aforementioned tools provide a solid foundation for various stages of the data science workflow, empowering data scientists to extract insights and value from data. Thanks for watching.